Hello, welcome to this Modurol video. This is video MT28 in our series of XK8 videos detailing how we converted our automatic Jaguar XK8 to manual using this Tremec transmission that's come from an Aston Martin Vanquish. Now, in this video, at the end, there's a bit of a turning point to the whole project, but more about that later. So I'm going to split the video into sections as per usual to try and get it into some logical sequence. First, I'm going to talk about how we corrected the gear lever position to the front flange of the bell housing. Then we'll actually look at how we've been able to move the gear position sensor from here to underneath the gear shift mechanism. Going to talk about how we've tried to reduce excess movement and wear in the actual shifter mechanism itself. Then we're going to actually look at this shifter mechanism and its origins, which is actually quite surprising. I wondered why this was so complicated, but I understand why now. More about that later. Then finally, we'll talk about the prop shaft clearance to the shifter mechanism and how that has actually become a turning point to the whole project. Okay, the first thing we're going to look at is the gear lever position to the front flange. So I'll grab the camera for a minute and try and help explain. So, you need to have 37 inches from the front flange to the middle of the shifter, and I've actually got that now. Just correct that. 37 inches, I think. Move that back a bit. There you go. So I'm fairly happy with that. How have we done that? So originally, when we got this gearbox, it had a bracket fitted on here. I think I've got it at the back here. It was bolted on like such, and the gear shift mechanism was actually 1.25 inches further forward. I can see the gap here that's been created. So I've developed these brackets to fit on the side. This was 5mm aluminium, so I've laser cut some 2mm stainless steel brackets to try and make it strong enough and not rusting. But on top of that, we've actually created another bracket for the other side. Unfortunately, the holes aren't on the side of the gearbox, they're actually on the top. So we've created this bracket and put some holes in the shifter mechanism, and that bolts on top. So actually, I probably only need one bracket either side, and that'll give a solid mount at the correct distance from the front flange. While we're at the back of the gearbox here, we can talk a little bit about this gear position sensor location on the top. So we're a little bit concerned about the clearance to the tunnel on the XK8. So it would be more logical if we could actually fit it underneath the shift mechanism. So actually, if we look under here, I've actually machined this away, and we've fitted another adapter plate on the bottom there for the sensor to fit. Let me just take this off and I can show you. I've undone the brackets on the other side, and let's just turn it over. There you go. Sorry, I've just lost a shim. Needed a shim there just to push the mechanism over ever so slightly. Actually 1mm, that is. So this is the machined aperture for this gear position sensor to be mounted underneath. Take that from there. This will actually drop in here. So I've done the same thing. We've created a PLA plastic adapter to go over the top, which is located with M6 cap screws, and the position sensor just sits over the top. So yeah, So it's sat underneath like that. I've moved the whole assembly so you can see a little bit better with the light. So there you go, that's it. It's pretty tight under there, but it is just about clear. And with the bracket, it'll cover that. And obviously I'll need to make a hole for this socket to come out. But other than that, it will locate underneath there, out of the way. So pretty happy with that adaptation. The next thing we want to talk about then is trying to eliminate excess movement in this shifter mechanism. So the first thing we looked at was actually this cantilever design of bracket. As I say previously, there was this aluminium bracket bolted just to one side and nothing on the other side. It was actually completely free. So what the gear shift mechanism can tend to do is actually bend over, particularly when you're trying to select reverse, which is over that way. The whole mechanism tends to bend. So what we've done, this is why we created this additional side bracket to support that side, which really stiffens the whole thing up. So that was the first thing. The next thing was actually the U-joint in the shift mechanism. There was actually a bolt here. Let me just get you a close-up of this area. Okay, starting at the transmission end. So when I originally got the gearbox, there was just a rough bolt in there, which obviously I didn't think that was proper. And the whole thing was moving. So I got a shoulder bolt, tried that in the location, and it's obviously no good. It's moving around, so there's quite a bit of wear in here. So what I've ended up doing is grinding a pin down, creating sort of a cotter pin. Try and do the nut on the other end. It does pull it tight. And there's no movement there, so sorted that out. The next thing was a little bit of play in the actual U-joint itself, so I bought another joint just in case there was some wear, but that seemed to have similar amount of play in it, so didn't go with that idea, so kept the original one. Then I actually thought, why don't I actually get rid of this altogether and create a straight connection, which is what I did. So then we've got this straight connection, which actually has no play in it at all, and we can, once this shaft is elongated, we can have no play in the mechanism at all, which would seem to be the way to go. Now the next thing was actually wear on this shaft. So the other way you can see this, I'll move the camera along a bit. So I've moved the camera along, I don't know where you can see that. There's a bit of play in there, in the actual bushings of the mechanism. So I've measured this shaft, and these are actually undersized, these shafts. I don't know if it's through wear or it's through on purpose, but it should be 14mm. So I've bought a new bit of silver steel at 14mm diameter, and that eliminates that play in the system as well. Obviously I need 1.25 inches longer shaft anyway, so that's got rid of that. One thing I've been curious for some time about this gear mechanism was the origin of it, and it was quite complicated. It's got this sort of spring mechanism on the top and this reverse lockout plate at the bottom, and quite a well-defined gear lever that looks like it's been carried over from somewhere. So I did a bit of research on that, and I've found out where it's come from. It's actually from an old British Leyland remote gear change mechanism, and I found one of the original ones on the internet, and we'll have a quick look at that now. if we just compare the two side by side from the top, you can see the similarities. So you've got the spring mechanism and the same lever and this reverse lockout. Obviously that's on the other side, but this is actually quite a well-defined casting, and I can't understand why the person who did this gearbox originally didn't use this original casting, because the beauty of these remote shifters, if they've been designed with isolators, there's bushes that can be mounted here and here that act to reduce the vibration through the transmission onto your gear lever. Also, there's actually a rubber, I don't know if you can see here, there's actually rubber in the actual gear lever itself, which further helps to reduce our vibration. Obviously I've got that on my lever, but this actually gear mechanism then is for an LT77 or R380 gearbox with a remote gear shift requirement, normally rear wheel drive V8s from British Leyland from years gone by, in particular the Rover SD1 and the TR7, but I believe it's also been used on Morgan plus 8s and plus 4s from the 1980s to the 2000s. So there you go, quite interesting. What was revealing as well was how the shift, the reverse lockout worked. It's actually a mechanical reverse lockout. So I'll take this plate off and I'll try and show you how that works. So I'll remove this plate off the bottom, and it shows you this mechanical reverse lockout mechanism. So the idea of this is that the gear lever is being held off the gears by this plate. So imagine on your British Leyland car, the reverse would probably be up here somewhere. So you've got to move the gear lever to the left, and this plate prevents the gears lever going to the left. But ingeniously, it's actually sprung loaded. So if you knock it hard enough, it will actually go over to reverse like that, or move over. And that's basically how the mechanical reverse lockout works. So normally, if you're not applying excessive pressure, just moving up and down the gears, it won't go into that part of the gear shift. But if you use a bit of force, and you can adjust the force with these two bolts and nuts here, and effectively it prevents you selecting reverse by accident. So what the guys that have done when they're doing this Tremec version is the reverse is actually on the opposite side to what it was on the British Leyland. So they've actually moved the reverse lockout mechanism from the right hand side of the shifter to the left, and you cannot push the lever over into reverse because you've got that mechanical system. Obviously you can give it a knock and it will select reverse. So that sort of is a mechanical system for preventing you selecting reverse by accident. Lastly, I've got the gear shift mechanism somewhere handy, somewhere where I'd like it. Got rid of all the play, and so lastly I just wanted to check the clearance, because obviously on that British Leyland shifter there's a plate underneath protecting it from all the dirt and debris that gets thrown up. So I wanted to make sure we got enough clearance to the yoke and this universal joint. I don't know if you can see here, you can see that the shift mechanism without a plate looks very, very close to the input, or so the prop shaft. So in theory I need to move this whole thing up, which means I need to start using universal joints and applying some sort of play into the system, which I've just worked out getting rid of. And then I found a major problem with this particular build. The output shaft on the Tremec is actually a 30 spline male shaft, and on the drive shaft, I don't know if you can see that there, it's a female splined slip joint or slip yoke. Unfortunately, the drive shaft that was supplied with the kit when I bought it has a 28 spline slip yoke, so the two won't go together no matter how hard you try. I've measured it up, it just doesn't fit. So this actual joint here is actually a 1310, and I need to change this slip yoke for a 1310 by 30 spline. But you can see here it looks very close. The clearance is quite close. The only slip yoke I can find is actually a 1350, which actually is larger, and chances are it's going to hit the top of this. So then I start to question about the shift mechanism. Is it maybe too low? Do I have to bring it up, take it up? And then also this drive shaft. Is it really worth trying to swap that? I can't find a slip yoke compatible. The one I can find, it interferes with this, and the problems just go on and on. It really begs the question, am I doing the right thing? Is this the right way to go on the project? Have I chosen the right gearbox? Okay, there you go. Hope you find that interesting. That's as far as we've got with the shifter mechanism on the Tremec. And in the next video, we've got a bit of an announcement, as you can imagine. Anyway, hope you're enjoying this project. We've not finished. Please like, comment, share and subscribe for more XK8 videos. Bye-bye.